Okay, welcome to video number 23 of the Diaries of a Coronavirologist YouTube channel. Today is the 20th of May and we are very close to 5 million confirmed cases. The Johns Hopkins tracking site that I always use has the case count at 4.968 million. And the same site also has us at a little bit over 326,000 confirmed deaths. So the video I had planned to do today was talking about the origins of this virus, or was going to talk about the origins of this virus. As I'm sure everyone's aware, there's been a lot of conjecture recently about whether this virus came from a lab or whether it was man-made and all those kind of things that don't have any evidence to support them. So I want to do a video to talk about all of the strong evidence that suggests this is a naturally evolved virus. That this came from Mother Nature. It did not come from a lab. So I will do that, but to be very honest, I had a bad night's sleep last night, and I don't think my brain can appropriately explain all the logical jumps in a succinct way for why I say there is good evidence for the fact that this evolved in nature and wasn't from a lab. So I'm going to save that for when my brain's functioning a little bit better, because I need to do it proper justice. Instead, what I'm going to do is talk a little bit more about vaccines. So in my last video, I talked about the ChAdOx vaccine. So I talked about what that vaccine was, how it's designed to work, and I talked a little bit about a paper that was published on the 13th of May that suggested it was working in monkeys, and I was very optimistic about it. Now, since then, as of I think Monday this week, there was an article published in Forbes that gained quite a lot of attention because it was very critical of the study and basically argued that it didn't work, or that the vaccine didn't work, and that we shouldn't be excited by it. So I want to go back into the paper in a little bit more in a lot more detail and go through everything that was in the paper to explain why I think we can be optimistic and that it's not as bad as it's suddenly being made out to be. This video is also going to include questions at the end, so I'm going to go through the paper piece by piece, talk about what was shown, why I think we can be optimistic about the results, and then I'll do a few questions at the end. So it's one of the slightly longer videos, but that's because there's questions at the end. I'm not going to be talking for ages about the paper, but there's some timestamps down in the description if you just want to get a sense for how long every part of this is going to be. So the paper that I'm talking about, I'll post the link to down in the description for the video. And it's a bioRxiv paper. Again, I talk about bioRxiv quite often at the minute, but it's not a peer-reviewed paper. It's just been published on bioRxiv as a post of here is our data without it being peer-reviewed in the normal way science is published. And the title of it is ChAdOx COVID19 Vaccination Prevents SARS2 Pneumonia in Rhesus Macaques. So rhesus macaques are a good model for studying humans. They're closely related and they're often used. But the first thing I want to point out about this study is this model of using rhesus macaques and SARS2 infection to try and model COVID-19 isn't fully established yet. We've not had the time to work out all of the parameters to use. So how long to do the infections for, how much virus is a good amount to use, how much is too much, how much is too little, how old the monkey should be. Does age impact the disease in monkeys as it does in humans? All these kind of things we haven't fully established yet because we just haven't had the time. This virus hasn't been around long enough to do all of those appropriate studies. Monkeys aren't that easy to work with in any lab. I should also point out that the work that was done, give credit where it's due, of course, the monkey work was done at the Rocky Mountain Labs here in the United States, and it was in collaboration with the group in Oxford that developed the ChAdOx vaccine. So it's two lead authors on the paper, which are Sarah Gilbert and Vincent Munster. And yeah, it's just those two that are the lead authors, so I had to check. So as I say, first thing to note is this model is not fully established. Things are being rushed through, looked at as quickly as possible to try and get a vaccine as quickly as we can, to know that it's safe to use in monkeys, that it might be effective, and therefore to give us the impetus to trial it in humans to see if it's safe and potentially effective in humans. And obviously, as I said in my last video, there have now been over 1,000 people who've received this ChAdOx vaccine in Oxford, and there's no reports of any adverse reactions yet. So the very first part of this study was actually in mice, not monkeys. So the group injected mice with the ChAdOx SARS2 spike vaccine, or a control vaccine that produces, instead of spike, a protein called GFP, green fluorescent protein, as a good control. And they found that their SARS2 vaccine produced an antibody response that was protective. So they collected antibodies from the mice, and they found that those antibodies could inhibit infection with SARS2 virus in the lab. So they produced a neutralizing antibody response, whereas the control mice did not. So this is then a good starting place to take that vaccine and go into monkeys and start to do your vaccine study in the monkeys, which are a much better model to use for studying responses in humans. So they gave a singular dose of their vaccine to the monkeys, either the control or the real vaccine, and then waited 28 days. So there was no prime boost, which is a good way to get a better vaccine response. It's often seen that if you inject once and then inject another time, you get a stronger immune response. They just did a singular injection, waited 28 days, and in that time course, they looked to see if there was an immune response. And similarly to what was seen in the mice, the monkeys that were injected with the SARS spike vaccine developed a anti-SARS2 antibody response. They developed neutralizing antibodies that, when looked at in the lab, those antibodies were capable of inhibiting SARS2 infection of cells. So the vaccine worked. It produced neutralizing antibodies to the virus, whereas the control vaccine did not. So over that 28 time course, the monkeys showed signs of the vaccine taking effect. And after that, they were challenged with the virus. So the control vaccine monkeys and the vaccinated monkeys both received a challenge of the virus, and they received a high dose of the virus. They received it in both the upper airways and the lower airways. So they had it just injected to their nose or right down into their lungs. So again, another point here, that's not really how a human's going to be infected. A human is not going to receive virus in two locations like that. You're not going to have it forcibly put into your lungs unless you're very unlucky in a hospital with a ventilator, I guess. So it's not really a natural way an infection would occur. And that comes back to the fact this model isn't necessarily well established. They haven't worked out all the parameters. This just works, so let's use it for now because we need the data to see if this vaccine might actually provide any benefit or not. So, and like I say, they use a high dose, so they used over 1 million particles, and I've seen other studies using monkeys that I'll probably talk about in a few days' time, or a few videos' time, that used much lower doses and still got infection. So this is a very high dose of virus as well in a very artificial manner. So it may not necessarily mimic a true infection, but this is how it was performed, and they managed to infect the animals this way. So at this stage, we've got 6 monkeys that have been given the SARS2 vaccine, and we've got 3 monkeys that have been given a control vaccine, and all have now been dosed with virus. Over the next few days, those monkeys were followed to see what happened, and in a blind manner, so someone who didn't know which group was which or how the monkeys were all divided up, looked to see if they showed any clinical signs of disease. And it was found that all the control animals, as it turned out after being unblinded, developed a higher respiratory rate. So they had shortness of breath, similar to humans. And 3 of the 6 vaccinated animals also developed this shortness of breath. So this is one of the criticisms that was made of the paper, saying that it didn't work. Okay, 3 of the monkeys developed some kind of clinical disease, but we can delve further into that. So to look in more detail, they started to try and investigate whether there was actual virus replication going on. And a criticism I have of the paper is that they didn't actually ever look for real infectious virus, but I'll come back to that. So in all the animals that were infected, over 7 days after they were infected, the samples were taken from the upper airways, so nasal swabs, and from the lungs, so using bronchiolar alveolar lavage, so taking BAL fluid to get samples from in the lungs. Now in all the control animals, so not the control vaccine animals that were infected, They all showed signs of having the viral genomic RNA on every single day, but only on two of the days, so day 3 and day 5, did they have evidence of actual replicating viral RNA. So it's possible with coronaviruses to look for RNA that is evidence of actual replicating virus, not just the genome. So if you just take the virus that they put into the monkeys at the very start, you can find genomic RNA, even though that virus may not infect at all. You don't even need to put it in a monkey, and you could find genomic RNA from that. But you can't find the subgenomic RNA, which is the terminology they use in the paper, so sgRNA for subgenomic RNA. That is true evidence of replicating virus. And in their control animals, they found that evidence of replicating virus on days 3 and days 5. So in the vaccinated animals, there was evidence of genomic RNA in the lungs, 2 of those animals, on day 3 and day 7, but only those 2 days of detection. And there was no evidence of the subgenomic RNA. Sorry if I say guide at any point, there is something else that's gRNA, genomic RNA, and guide RNA. There was no evidence of any subgenomic RNA in any of the vaccinated animals down in the lungs. So this suggests the virus wasn't getting into the lungs and it wasn't replicating. It suggests that the vaccine is protecting from virus getting into the lungs. Now, like I say, they didn't look for any infectious virus, which is a much better way to determine this. But just looking for the RNA, they didn't find evidence of replication in their vaccinated animals. Now, they did find evidence of viral RNA in the nasal washes of all of their animals. So all of the vaccinated animals had the genomic RNA in their nose, as did all the control vaccinated animals. But what this is suggesting at this stage is that the vaccine is protecting the monkeys that received the vaccine from developing a lower respiratory tract infection. And that's the more severe form of this disease. If it's just in the upper respiratory tract, it's just going to largely manifest as a common cold and the more mild symptoms. So it looks like it's protecting these monkeys from severe disease based on where the RNA is going. And remember, they put virus right into the lungs. So it's not like it's being blocked transmitting down from the nose or anything like that. So it does look like it's protecting at this stage, even though some RNA can be recovered. And the other important point about just looking for RNA versus actually looking for real virus and looking for the subgenomic RNA is that RNA from this virus seems able to persist in people. There's more data coming out of studies in South Korea that suggest that people who have been infected can still test positive on RNA, but be negative when looking for real virus. So it seems like the RNA can persist, but that doesn't mean that you're infected or reinfected. You're not actually producing any infectious virus. So this is why I say the better way to do this study, in my opinion, would have been to actually look for real virus. But having just looked for RNA, they don't get strong evidence for any replication of virus in the lungs, which, like I say, leads to an idea that maybe this vaccine is protecting against more severe disease. And indeed, when they get to the end of the 7-day infection time course, they euthanize the animals and look to see for pathology. They find in their control vaccinated animals that there is evidence of virus replicating in the lungs and there is evidence of viral pneumonia. So there is lung damage going on in these animals. But in the vaccinated animals, there is not evidence of pneumonia. And there is also no further evidence of virus being in the lungs. So I should point out, while I was just checking my notes, that it was 2 of 3 of the control vaccinated monkeys that had evidence of viral pneumonia. It's not even all of those developed pneumonia, which, again, coming back to this idea that this model system isn't all perfect and doing everything you'd want it to really assess. But again, the evidence is that the vaccine is protecting these animals from severe disease. Virus doesn't seem like it's infecting in the lungs and it isn't causing damage. It's protecting these monkeys. And that's how this paper draws its conclusion that is the title of Prevents SARS-CoV-2 Pneumonia in Rhesus Macaques. Yes, RNA was recovered from the upper airways of the monkeys. Maybe it suggests that there can be some degree of infection the vaccine isn't necessarily completely blocking any infection, but it's very clearly preventing severe disease. And the reason I'm stressing that we can still be optimistic about this and not as pessimistic as the articles that I've read that are criticizing it is I'd take that over anything right now. If all we get is something that prevents severe disease and makes this into a common cold, sure, that's great. And that is how this paper looks like it's working. Now, that's just my view, my interpretation of this, and maybe I want to be overly optimistic about it. As I've said along the way, I do have some gripes in terms of they didn't look for actual virus, replicating virus, to see if they could recover any from any of the animals, to see if they could be spreading virus amongst themselves and all these kind of things. And it's a small study, 6 monkeys versus 3 monkeys, and 2 out of 3 developed pneumonia and all these. It's a small sample size, but it's evidence that this vaccine is doing something beneficial. And as I say, it's enough data for us to look to try it in humans and make sure it's safe in humans and it isn't causing any adverse disease. And that's being done. As I say, over 1,000 people have now been injected with it in Oxford. So we're going to learn a lot about whether this really does work over the coming months. And that's where I'll end this video for today. To briefly summarize, the criticisms that were made of this paper were largely that it doesn't provide sterilizing immunity because you can detect RNA from some of the vaccinated animals. And sure, that is a valid criticism and a valid concern. However, there is good data in here that the vaccinated animals did not develop a severe disease compared to the control animals. So if the vaccine works by just making this into something like the common cold, that's still great progress compared to having nothing at all. And the more candidate vaccines we have going into stages in humans and being shown to be safe and being shown to have any effect at all is all good forward progress. Eventually one will win out and we'll have the best vaccine that can be given. But then you run into manufacturing issues and all these kind of things. So the more candidates we have and the more ways we have to tackle this virus, the better off we are. So even though there was, at the start of this week, quite a lot of criticism articles of this study or things downplaying it and all that, I still think we can maintain optimism about the ChAdOx vaccine. Anyway, I will finish out the video with a couple of questions as I'm sort of still toying around with the idea of including these before I close out. So let me just pull up some questions. So most of these are coming from my last video, and the first one I want to tackle is that it was brought up by certain people in the media that there may never be a coronavirus vaccine because we've never had a coronavirus vaccine before, and what makes this one different. So the biggest thing for what makes this different is the fact that there is a huge impetus and a huge scientific effort and industrial effort and money going into making this. Before, we had SARS-1, which in a matter of 7-8 months caused 8,000 cases. Wasn't really enough cases to even test properly to see if a vaccine would work, let alone develop one and trial it, because cases just didn't spread as rampantly as this virus is. With MERS, in 8 years, we've only had 2,500 cases. Again, not really enough impetus to develop a vaccine. And for the 4 other coronaviruses that cause human disease, they just cause the common cold, for the most part. There is no desire to produce a vaccine from the companies that would have to fund it and all that kind of stuff. The difference here is that there is a massive drive to develop a vaccine. And there are so many candidates. I think there's over 120 different candidates being trialed at the minute. I'm probably not going to talk about them all on the channel, but there's a lot of things being done. So I am confident we will develop at least one, if not lots, of vaccines to this virus. So the next question was about whether antibody tests are reliable enough. And generally, that's not well established yet. The antibody tests are something I'll probably do a full video on to talk about in more detail, but there's been a sort of weird way that the antibody tests have now been authorized, at least in America, and a lot of them don't necessarily have the stringency they need. So we really need these to be incredibly accurate. From things I'm seeing right now, they're not. They'll get there, but right now they aren't brilliant. The studies that are done in the papers where I'm talking about the vaccines to say we're looking for neutralizing antibodies, those are very reliable because that's a biological experiment. We take antibodies, we mix them with virus, then we try and infect our cells with that virus, and if we see that the virus can't infect the cells, it shows those antibodies work. But that's not the kind of test that's being done on people to see if they have antibodies that suggest they've been infected. So in terms of working out if vaccines are producing effective antibodies, that's reliable. But to work out whether humans have been infected already in those serological studies, that's a little bit questionable still. And the final question I'll tackle also concerns antibodies. So under an assumption that serology testing was perfect, if people test positive for the antibodies to SARS2, suggesting they've already been infected, would they need to get a vaccine? And I think generally, yes. With seasonal coronaviruses, the ones that cause the common cold, we see that the antibodies that people produce that are protective only last for about a year or two at most. So the immunity wanes over time. A vaccine would be expected to produce a better antibody response. So you can add other things into vaccines called adjuvants that can enhance the immune response you develop, which may make it better and longer lived. So even if you've already been infected with SARS, it may still be beneficial to get a vaccine. And I'm sure that as part of the trials that will be performed, that kind of thing will be looked at. So looking to see if people are have already developed antibodies and to see how the vaccine affects them and whether it's any different. But right now, the thought would be, or the thought I have is that it probably would still be worth getting vaccinated, regardless of whether you've already been infected. And the other part of the question was about whether antibodies from people who have been infected could be used for treatment from the plasma. And yes, that's being done. Convalescent plasma is being used. And from the little bit I've seen, I need to look in more detail, admittedly, but the little bits I've seen suggests it's looking promising. And that if you can take antibodies from people who've been infected and put that into people who are suffering disease, it can actually be helpful. But like I say, I need to look at that in more detail to confirm properly. So that's where I'll end tonight's video. As always, if you're finding these videos useful, please recommend them to people. Please subscribe if you haven't already so that you'll get notified when I put up new ones. I try and put them up at least a couple every week. Drop a like on the videos, all those kind of YouTube metrics things, and please leave questions and comments. As you see, I will try and tackle the questions either by writing responses or doing them in the videos. And help me provide the information you'd like to hear, I guess. Anyway, as always, please stay safe, wash your hands, and keep calm and carry on. We will get through this pandemic.